Welcome guys. Today's knowledge session is about the seal secrets, a secure way to manage seals secrets in our particular Kubernetes. So this tool is mostly work on the Kubernetes secrets. So before starting the session, we will see the some of the knowledge etiquettes. The punctuality join the session 5 minutes prior to the session start time. We start on the time and conclude on the time. So feedback, make sure to submit the constructive feedback for all session as it's very helpful for the presenter. Silent mode, keep your mobile devices in silent mode. Feel free to move out of session in case you need to attend an urgent call and avoid the disturbance. During the avoid the unwanted chit chat during the session. So today's agenda is first of all, what are the Kubernetes secrets? Then we will see why to use seal secrets. Then the components of the seal secrets, how it works, and then the advantages and the competitors of the particular seal secrets. So first of all, what are the Kubernetes secrets? So the secrets is an object that's contain a small amount of sensitive data such as password, token, or the API keys we use for our particular application microservices. So these secrets can be mounted as a data volumes or exposed as environment variables to the containers in the pod. So as per our requirement, and we sometimes we use as a data volumes. So and environment variable also, but mostly we use the data volumes to attach our particular Kubernetes secrets to the microservice or any pod or deployments. Then we will see why to use the seal secrets. So first of all, I will say that the Kubernetes secrets, the data which we save, such as password, username, token, or API keys, those are just the base 64 encoded. So those are not encrypted. So it's easy to encode that particular tokens, password, or API keys. So that's why we use the seal secrets. So seal secrets provides a mechanism to encrypt a secrets object so that it's safe to store even to the public repository. Seal secrets can be decrypted only by the controller running in the Kubernetes cluster. So nowadays, most of our projects are we deployed through the GitOps method. So during this GitOps method, the access of the that particular project's repo is to the multiple teams such as developer, test teams, or anything or other teams. So what happen if we deploy place of all the files of the clusters of the YAML file secrets files of that our particular microservice, we put in one repo. So anyone who has access for that repo, he can check our particular secrets and just the base using just the base 64 encoding, he can easily see the password of our database or the API keys or the session tokens of our particular Kubernetes system. So that's why we use the seal secrets it's a provider encryption key for our particular Kubernetes secrets. So it's not get difficult to encrypt someone because without having the access for the control which are running in a Kubernetes cluster, they will not be able to see our sensitive data. Then the component of the seal secrets. So it's just a basic two component. One is a cluster side controller, which get deployed in our Kubernetes cluster, and another is a kubectl. So it's a CLI, just a CLI. So first of all, controller is responsible for managing the sealed secrets deployment. The primary task for the controller is to manage the private and public key for encryption and decryption purpose. So when we install this particular or deploy this particular controller in our cluster, so it's create one private key and one public key. So private key is get stored in our cluster in a secret, is generate one secret of that, and the one public key is, generates which we can use in our particular cluster or outside of the cluster, as we can say on the client systems or our local systems where we are creating these particular secrets for the encryption of this particular or normal Kubernetes secrets. And another one is a kubectl. So it is a CLI tool that's create the search for sealed secrets for from a secret. It's communicate with the controller and retrieve the public key need for the encrypting the secret. So if we are just directly creating the sealed secrets of our normal secrets in our cluster, so it will go to the controller and first of all get the public key for encryption purpose, because in our particular cluster in the seal secrets, the public key is used for the encryption purpose, and in cluster or when Kubernetes when after deployments and all of that in particular cluster, the decryption is done only using a private key saved in our particular cluster. So all of this for sealing for normal seal secrets to seal it, we use a kubectl command. So those are the just the two components which are using in a seal secrets. So now after seeing the components, we will see how it's work. So as you can see, there is a Kubernetes cluster. So there are the two namespace. One is default, and we can see I have used here a seal secrets. Or normally most of the times controller is get deployed in the namespace called kube system. So here, first of all, we create one cluster, then we deploy the our controller as per our need in namespace as per our requirement. So we can create one special namespace for our seal secret controller, or we can use a kube system. So mostly the kube system is get used. After getting deployments, it's create one private key is get stored in our cluster, and it's gives us one public key which we can use. So this generated public key, mostly all of those who are using these seal secrets, they use in their local site where they want to do the encryption. So here is one client which has created one secret. The kind is when we normally, as you have seen in Kubernetes secrets, it's the kind is get created is a secret. After using this public key which we have given from the controller, or we encrypt that controller particular secrets, and it gives us a kind seal secret. So in encrypt that particular data which we have put it in our secrets. So after getting encryption, we can easily push our the secrets in a GitHub. So even have multiple teams have access for that particular secret. He will not able to encrypt or see our sensitive data or sensitive data. So when we sync our particular Git repo to the cluster where we have deployed the controller of that public key, it will detect that the some seal secret is coming in our particular cluster. So using the private key, it will decrypt that, and it will provide the encoded base data to our cluster, because Kubernetes cannot able to recognize the encrypted data which control is created. So when it's get in a cluster, controller will be automatically decrypt that using a private key, and will be able to see the normal secrets in our particular cluster. So this is how it works. So you can get the better understanding when we will do the demo of this. So there are advantage of the seal secret. As you have seen, there are only two components which you have deployed on our cluster for the management of seal secret. So it's very simple to understand. It's GitOps friendly. So mostly it's used where we given the access of a particular repo to the multiple team. They can so that our secret is get easily compromised. So that's the place where it's mostly used. The public and private key which I have created is create one strong encryption for our particular secret, so no one can be able to decrypt that particular secret without our controller deployed in our Kubernetes cluster. It's easy to integrate. We just need to deploy one controller in our cluster. It's get integrated with our seal secrets, and it's open source. So it's the best part that it's freely available open source, and the repo is got maintain that particular uh, sales secrets. Now the competitors, so mostly there are multiple. So there is one secret operations. There is a HashiCorp Vault. There is a KMS plugin, so which a cloud specific, so such as a AWS key management system, Azure key management system. There is a also for the Google key management system also. So there are the cloud specific, and then Git also provide a Git encrypt. So, but it's not as much. So it's not easy to use as we have seen the seal secrets. So so, so SOPS is also the open source secret operation, but it if you have see the integration of that particular secret, there are multiple components we need to integrate with our cluster. So it's consume the lots of resources. So we doesn't use a SOPS that much. So HashiCorp Vault, KMS Cloud Specifics, these are not the open source. So we need to pay some cost for these particular vaults or a cloud specific plugin. Those are also easy if we are using specific cloud. But for the open source or for cost optimization, we should use the seal secrets. So as per demo. Now we will move toward our particular demo. So here I have taken the killer code of Playground. So it's they have deployed the 1.28 Kubernetes clusters. If you can, yeah, so there is a one control plane and there is one node. So Kubernetes cluster is get deployed. So first of all, as you can see, I will see the particular project open source repo. So this is the repo of the seal secrets. Here you can get in details of the. So it's basically uh, developed by the Bitnami Labs. So they have multiple projects. So this is the one of those. So first of all, when a deployment of this particular seal secrets, we need to deploy the one controller and kubectl. So if you can see on that particular source, we can see there is a latest version is 0.23.1. So for deployment, first of all, we will download the controller. Yeah. So from this particular website, I have taken the controller.yaml file. So there are different types. You can deploy this particular controller. There is a one .yaml file, or you can deploy using Helm charts also. So there is a provision for the deployment using Helm charts. So mostly they are using Helm charts in our project. So here there is a repo available in the Helm charts. You can download using that also. So that particular YAML file deployment, now we can use the kubectl apply for deployment of that particular controller. So there are multiple resources is got deployed when we do the control. It will take a few minutes. Yeah, so as per you can see, it's create the service account, role account for our particular controller. So we can it's create a cluster role. So we can access this particular controller throughout our cluster. So it's get easy. Now, as the second part which we need to deploy is a kubectl command. So this part CLI also we can get from here. So it's for a different Linux, Windows. As per our requirement, we can use this CLI. Mostly we deploy in our cluster or in a local also we can deploy it. So the latest CLI is get deployed 0.23, and we have deployed one controller. So the controller is the one type of deployment. So it's a after getting deployed, is create one pod and maintain that the replica, because in our particular deployment we have specified the replica for the one. Okay. Yeah. So here you can see. I think it's not deployed currently. There is some problem. So it's getting deployed. Controller is get deployed. So it will take some times for deployment of that. There is some problem for the controller. So it's not getting paid. It will get deployed. If anyone have any questions, they can ask. think it's taking more time than usual. Can get a new background for this. I think it's getting some problem because I have used it before. Sorry, guys, I think this issue is what I will get. I will check the logs. Wait for me.
So,
Yeah, I'm deploying it using Helm. Wait a minute, it will be get
okay,
deployed. Yes.
okay.
Yeah, guys. So it's got deployed. I think it's taken.
There is your screen is not visible.
Yes. Uh, is it visible now?
Yes, yes, there
Yes,
is.
it is.
Yeah. Okay. Yeah. Now, as you can see, so the pod is, I think, getting delayed. It's got deployed now. As you can see, it's got deployed now. Cube system namespace. It's a seal secret controller. So if we check the logs, so first I have told you that the when this particular pod is get deployed or controllers get deployed, it will create one private key and session key. So for that we can check the logs of this particular. Here you have, you are able to see when we check the logs. First of all, it will secret controller version, it will search for the existing private keys. If there are any private keys are available, means if we have created one controller before, so it will check if it's available or not. Or if not, so it will create one new system, one private key and the public key, if you can see. So just this certificate is got generated. So using this, we can we encrypt our particular seed secrets for the private key, if you can see. So here is, if you are able to see, this is the key. So this is the private key is get created by the controller when this it's got deployed. So normally, if you able to say or normal, so I will create one normal seed secret, normal secret. So this is the type, the normal queue. Initially we used to create the secrets. So this, if you are able to see this username password, so they are just the base 64 encoded. So they are not the encrypted the way we have encrypt seal secrets are done. So if I so anybody can just take this and encrypt this particular. I will just show the next session. Yeah. So if we do echo, base. So if you normally anybody can do this encoding just only. If you are able to see, this is the password I have saved there. So if we put this particular file in our repo or anything, so anybody can just copy this and encode it in their particular local, because there is no key or any access required for this. So to encrypt this, we will use particular command. If we so for encryption purpose, we use a kubecl CLI. So first of all, we give the file which we want to encrypt. So currently we are running in the cluster where the controller is generated. So we didn't need to give the particular public key for that, and it will just get the file path, the output where we want, and we just read the file. So if you can see, there is a one file is get created here, still secret file. So here the previously we directly, if you can see the file, show you the, yeah. So this is the first. We just use the base 64, but now after encrypting, we didn't deploy it. Currently, we are just sealed it. So here the kind is get changed. So before it is a secret, so now it's the sealed secrets, and our password and data is got encrypted. So no one can able to see what is our sensitive data in this particular file. We can, this is the one file. If you want to do this or particular your local file, so first of all we need to fetch our particular public file which created by the controller. I will show you this. So that particular public key is got stored in this particular secret. So when we want to, if you want to seal that particular secret in your local, you just need to give the path of that particular file. And you do the same, you will get the same output which we have seen here. So you will, by doing the hyphen hyphen cert, we just need to give the file public key which we want to for the encryption purpose, and the same the format and all of that. This is the same as data for. The difference is only we are first we have used command for the deployment in our cluster, and one a second one is at the local. So mostly we then get that particular public key and use in our local and encrypt those, and then we push in particular GitHub. So after getting, just by using a kubectl command, we can so if you can see, I will show you the. So this is the name of our particular secret which I have created. So this is the secret is getting. If so, we have created in a seal, but now if you want after it's getting deployed, you can see it's automatically get in a 64. Yeah. So here you can see after it's get deployed in Kubernetes cluster, it's goes to its previous the base 64 encoding, because Kubernetes can't understand the encryption format. It's only recognize the base 64. So controller is again decrypt it. So at the initial, I have told you that without a controller, no one can be able to see this in base 64 format. So now they have given a new as the project is get means upgraded, so they have provided new ways for encryption. So our particular controller create a new encryption key after a certain time. So the basic if you can see the default time is 30 days. After 30 days it will create a new encryption key, and using that, if we create a new seal secret, it will use that newly created seal secret. So if we want to change that particular period, means we want to increase the period to the some minutes, or we want to make it zero, we need to do some of the changes in our controller file. So for that, this is our particular. So here is the retention period. Yeah. So the containers here we can provide the retention period as per our need. So for the practical purpose, I will show give you one retention period. Here is Yeah, so this is the command which we need to give hyphen hyphen key hyphen renew hyphen period. So this is only we can provide in a minutes currently because we can't provide in a day. If we put here 0, the key will not get be renewed. So now for the back, I will just change this to the 2 minutes. So it will show us. So if you can see, there are a new key generated because we have changed the renewal period to the 2. So if we seal another key, it will be taken this newly generated key. But the one we can say drawback is that there is multiple keys are got generated. So when we want to convert these or we want to transport this particular seal secrets or controller to the another cluster, we need to take the backup of this whole number of the keys. If we delete some of these keys and if we go for the encryption purpose, it will be not provided. So first of all, while deleting controller or if controller is got deleted, we need to make sure all the backup of this particular master keys we should take in advance. And now for the safe side, we should encrypt the encrypt our seal secrets as per as the new keys got generated. It will show us.
So this renewal, it is automatically generated by the seal secret.
Yes, it will be automatically generated. So if
So it will
the
fetch
file
the file from there, no?
no, so it is a there is a tool. We need to renew that particular key new with the new key. But we you can encrypt it using the backup key because it will not delete the previously generated keys. If we want to
Okay.
maintain all our secrets in only single, either you can make the renewal period 0, or if we want to maintain all the with a single, you can re-encrypt it or renew all of those key seal secrets at a time after means you have given some 1 month, so you can renew those all of the old secrets with this renew key for the renewation purpose. First of all, I will yeah. So if you as you can see, there is a new key is got generated again.
Yeah.
So for the renewation, so first of all, we should always take a backup of our particular master files, which the key are created by the controller. So for that purpose, we can use this command. So first of all, we will get secret. The label of our particular is seal secret. So it will get the all of this file in that, and it will store in this particular master file. So I will check in this and we can do the master file. So here you can see there are the multiple means the number of keys which you have generated, all the backups is get here. So there is no problem if one of our seal secret means we want to encrypt our seal secrets, which is old. He can automatically take the backup, automatically take all the private key from this particular master file.
Okay.
Yeah. This is the way you can re-encrypt our with a new seal secret file. Yeah, so this is just an easy way. You can just re-encrypt it. There is nothing you need to do. Just we need to show him our old
Secret
seal
file.
secret
Yeah.
file. Yeah, it will just re-encrypt it. So the best part, if you are doing all of this in a cluster, so you doesn't need to give the certificate which are generated by means the public key which is generated in the cluster. It will automatically take the latest one and re-encrypt it. That we will put it in a .tmp file and move it to the So it will be automatically detect, and the old seal secret file will be get encrypted with the new one. So this is the file. So it's very easy to re-encrypt. There is nothing. So if you have multiple seal secrets, you can automate this process because you doesn't need to provide the latest public file location. So this is the one best feature they have recently included in this. So you can, if anyone have questions, they can ask me. So this is the best one. Anyone have any questions regarding that?
So one question, Dheeraj.
Mm.
So when you generate the backup now, so it contains data and the TSL key. So it was
Yes.
encrypted one or it was clear plain text?
Yeah, so those are the encrypted one only. So means as per if you have seen first of all when we create any VMs or that there is a one SSH key is got generated. So it's
Yeah, yeah.
create one file, one private key and one public key. So it's the same way. The private key we can't means it's a place in our particular VM. So that's the same way. The private key is maintained by the controller, and the public key is got we get for the login purpose. So same is maintained by this one. When we get the backup, it will get the both the certificate and the encryption file both.
Okay. Okay, Dheeraj. Thank you.
So anyone might think if sometimes our control is got deleted or something like that. So there is no need to panic because we have the master file. You can see. So there is a master file. We have taken the backup of the master file. We just need to make sure this master file is also got maintained outside our cluster. So if the cluster control is got deleted or something happened to our cluster, so we can easily reinstall. So if you, I have shown you the logs of our particular controller. Yeah, so here when you so you have seen these all these certificates. So we have put the renewable key, so it's creating the new files. So we can take these public files from here if we want. At the initial of the deployment of the controller, whenever you deploy it, it will search for the already available master key. So if control is got deleted, first of all, we should add our master key in our particular cluster, and then we should do the means deploy our particular cluster.yaml file. So it will be search, it will be check, yeah, the already private key is available. So it will be get that private key and all the secrets, the seal secret which we have created, we can able to encrypt on a particular cluster. So guys, is there anyone have any questions?
No, Dheeraj, not from my end.
No, there is. So it's a very easy tool to maintain. So that's why just we just need to deploy the controller and all of that. If you have see his the documentation, I will put the this project open source file. So it will be easy for all of you to read. Anyone want to follow this particular so it's very easy to understand. So that's all from my side, guys. If anyone have anything, they can reach me. Those are the only new concept here for the renovation and automatic renovation is we can re-encrypt. So those are the two things. So if anyone don't have question, we can wrap up this session.
Yeah, if we don't have any questions, we can give it a wrap. Guys, let us know if you have any questions now. We still have a couple of minutes left.
Yes. I think no one has any question. We can have this session. I think, guys, after reading those particular documentation, you can get hang. And if anyone got stuck anywhere, they can approach me then. Because this is the first time I think some of us are seeing, but it's already happened one time this session. So some of are know about the seal secrets, and those are the new candidates. They can approach me after reading those particular documents. So also I think we can wrap up session.
Chalo. ठीक है guys. Thank you
Yeah.
everyone for joining. We'll wrap it up right here. Thanks.
Thank you.
Yeah. Thank
Bye.
you for attending the session, guys.